All right, let's just address the elephant in the room. If you're gearing up for the IIT JEE, you already know that integral calculus can feel like an absolute monster. I mean, it's dense, it's highly complex, and honestly, the sheer number of formulas can be completely overwhelming. But today, we're going to change how you look at it. We're going to break down this massive subject into a structured, highly manageable explainer. I want you to think of this as your ultimate modular toolkit. We're stripping away all that confusion and giving you exactly what you need to conquer these problems with total confidence. Okay, let's dive right into this. We're using a level-up approach today. We'll kick things off with Level 1, the Calculus Undo button. Then we'll move to Level 2, your standard arsenal. Level 3 covers advanced tactics, Level 4 dives into definite integrals, and we'll wrap it all up with Level 5, an IIT JEE cheat sheet. So Level 1, the Calculus Undo button. You know, the biggest mistake I see students make is looking at integration like it's some scary, brand new monster they have to learn totally from scratch. But actually, scratch that. It's simply the reverse process of something you already know intimately. It's just differentiation in reverse. You already know the derivative of x squared is 2x, right? Well, integration is literally just hitting the undo button to bring you right back to that x squared. Just remember to add your plus c. That stands in for any of those unknown constants that vanished during differentiation. Seriously, whatever you do, always remember your plus c when you're dealing with indefinite integrals. Moving right along to Level 2, your standard integral arsenal. Look, every exam warrior needs reliable weapons, and for the IIT JEE, these foundational formulas are absolutely essential. They are your core arsenal. Notice how we visually chunked these formulas so they don't just look like a random jumble of math. We've got the algebraic power rules, those beautiful exponentials that thankfully just remain unchanged, and reciprocals that magically turn into natural logarithms. Grouping them in your mind like this is going to help your brain retrieve them so much faster when you're under that intense exam pressure. Now, what's really interesting here is when you pair these standard trigonometric integrals side by side, these beautiful patterns just kind of emerge. Sine and cosine do this little flip-flop with a negative sign change, while secant squared pairs up perfectly with tangent. When you see these standard trig integrals paired together, it becomes a coordinated dance, rather than just a bunch of isolated facts you have to force yourself to memorize. Next up, we have the fundamental special integrals. And let me tell you, these are massive for the JEE. When you start spotting specific structures, like seeing x squared and a squared together in the denominator, recognizing those exact forms acts as a huge time-saving shortcut. If you actually try to derive these inverse tangents or natural logs from scratch during the exam, no way, you will lose precious minutes. Spot the form, apply the formula, and move on. But you might be wondering, what happens when the exam throws a really nasty, complicated quadratic expression down in the denominator? You know, the classic ax squared plus bx plus c kind of mess? Well, this is exactly where you pull out the complete the square method. By manipulating that messy quadratic, you can elegantly force it into one of those standard special integral forms we just talked about. It's a brilliant tactical move. It literally transforms an impossible-looking problem into a standard plug-and-play formula. All right, time to level up again. Level 3, Advanced Integration Tactics. Sometimes that standard arsenal just isn't quite enough, and test writers love to lay traps with problems that don't fit the basic molds. That's when we use our first advanced tactic, the substitution method. This perfectly illustrates what to do when one function is basically hiding inside another. You simply let u equal that inner function, you find its derivative, du, and then you substitute them right back in. You are swapping those complex, messy x layers for a clean u equation, making the whole thing incredibly straightforward to solve. Then, we have it, the dreaded integration by parts formula. The integral of u dv equals u times v minus the integral of v du. Students usually panic when they see two completely different types of functions multiplied together, like say an x squared multiplied by an e to the power of x. This formula right here is your answer. But the real trap? The trap is figuring out which function should be u and which should be dv. If you pick wrong, the problem actually gets more complicated, not less. But don't worry, there is a literal cheat code for this. Behold, the ILAT rule. I'm telling you, this mnemonic is absolute pure gold for instantly knowing how to tackle biparts questions under pressure. It gives you the exact hierarchy of which function to choose as your U term. You just go down the list: inverse trigonometric, logarithmic, algebraic, trigonometric, and finally exponential. Whichever function comes first in that word, ILAT, boom, that is your U. The rest of it becomes your DV. Memorize this simple checklist, and biparts questions become totally automatic. Our last major advanced tactic is partial fractions. When you encounter a really complex algebraic fraction on the exam, specifically where the numerator's degree is less than the denominator's, this is your go-to move. It brilliantly breaks a complex fraction into separate, simple, easily integratable pieces. It's classic divide and conquer. Okay, so up to this point, we've kind of been living in this theoretical world of indefinite integrals, right? Finding general families of equations with that plus c. But what if we aren't just looking for an equation? What if we need to calculate the actual physical, exact area bounded right there under a curve on a graph? That brings us to level 4, the boss fight, definite integrals. Welcome to the boss fight. We are officially crossing over from abstract equations into the physical, boundary-driven world of geometry. And everything here relies on the fundamental theorem of calculus. So the crucial point is, instead of just writing plus c, you plug in your upper bound b, plug in your lower bound a, and you simply subtract the lower value from the upper value, big F of b minus big F of a. And just like that, it gives you the exact signed area between the curve and the x-axis. Now listen up, because JEE exam writers don't just want to see if you can calculate f of b minus f of a. They really want to see if you know the properties that act as shortcuts. For instance, integrating from a to a is 0. I mean, there's literally no width. Reversing the bounds changes the sign. But their absolute favorite trick? The symmetry property. The integral of f of x from a to b is exactly equal to the integral of f of a plus b minus x. If you master this specific symmetry property, I promise you, you will bypass pages of brutal calculations and save so much precious time. Let's move to our area formulas and see how this builds into calculating exact geometric spaces. To find the actual physical area, you take the integral of the absolute value of f of x. This just makes sure that those negative areas dipping below the x-axis are counted positively. And what if you need the area trapped between two distinct curves? Super simple. You just integrate the upper curve minus the lower curve over that interval, top minus bottom, and you've got your exact area. And finally, level 5, the IIT JEE cheat sheet. You've mastered the tools, you've got the tactics down, and you understand the geometry. Now, to actually maximize your points on the exam, you have to prioritize these high-yield topics. Get incredibly fast at completing the square for standard integrals with quadratics. Know the IIT rule backward and forward alongside your substitution methods. Master breaking down those rational functions with partial fractions. And finally, constantly hunt for opportunities to use those symmetry properties to save time on definite integrals and be completely flawless at setting up your upper minus lower bounds for the area under curves. These are the patterns that pop up literally year after year. We took a subject that honestly feels completely chaotic and turned it into a sleek, powerful, structured toolkit. You have the standard arsenal, you've got the advanced tactics, and you have the geometric understanding to tackle the hardest problems they can throw at you. But having the tools in your belt isn't enough. You've got to actually wield them. So I want to leave you with this. You've leveled up your calculus toolkit today, for sure, but exactly how are you going to apply these weapons to your very next practice exam? The roadmap is right here. Now it's time for you to go put it to work. Keep practicing, and I'll catch you in the next explainer.